Good morning, everyone. So, today we are going to start a new chapter of class ninth physics, that is the force and laws of motion, chapter 2. So, let's get started. So, here at first we have to cover that what is force. Force is something which changes or tends to change the state of rest or of the uniform motion of a body. The SI unit of force is Newton, and force is equal to mass into acceleration. The CGS unit is dyne. So let's come to the what are the effects of force. So force moves stationary objects, force stops objects from moving, and force changes the shape of a body. Force changes the direction of a motion. And now we have to cover that how many types of forces are there. There are of two types, balanced forces and unbalanced forces. When balanced forces are applied to an object, there will be no net effect force acting on the object. Balanced forces do not cause a change in motion. An unbalanced force acting on an object change its speed and on a direction of motion, and it moves in the direction of the force with the highest magnitude. You can see that first picture is showing the balanced force, and the second picture is showing about the unbalanced force. And now we have to learn that what is the net force. When multiple forces act on a body, they can be resolved into one component known as the net force acting on the object. The net force decides the direction of a motion. And the second force is frictional force. The force that opposes relative motion is called as friction, and it arises between the surfaces in contact. Example, when we try to push a table and it does not move is because it is balanced by the frictional force, as you can see in this pic. So let's come to the Newton's first law. A body continues to be in the state of rest or uniform motion in a straight line unless acted upon by the external unbalanced force. The first law is also called the Galileo's law of inertia. And let's learn about the inertia. Basically, all objects have a tendency to resist the change in the state of motion or rest. This tendency is called as inertia. All bodies do not have the same inertia. Inertia depends on the mass of the body. Mass of an object is the measure of its inertia. More the mass is equal to more inertia and vice versa. Inertia of a motion. An object will continue to be in motion until a force acts on it. Example, a hockey puck will continue to slide across the ice until acted upon by an outside force. And now we are going to see that inertia of rest. An object stays at rest and it remains at rest until an external force acting effects on it. And the examples are when the car accelerates, passengers may feel as though their bodies are moving backward. In reality, inertia is making their bodies stay in the place as the car moves forward. Now, the next topic is momentum. Impacts produced by objects depend on their mass and velocity. The momentum of an object is defined as the product of its mass and velocity. P is equal to mass into velocity. And it is a vector quantity but has a direction and a magnitude. Some examples of momentum include a baseball flying through the air and a bullet fired from the gun. Now we are going to see the second law of motion. The rate of change of momentum of an object is directly proportional to the applied force and takes place in the direction in which the force acts. The formula that we all know is that force is equal to mass into acceleration, or we can say that F is change in momentum by the time taken. Let's come to the third law of motion. Newton's third law states that every action has an equal and opposite reaction. Action and reaction forces are equal and opposite and acting on different bodies.